Geotrig, lesson 11, day 2. Now we're going to continue on past the inscribed angles. Remember, are half the intercepted arc. We could talk about the product of the length segments of a chord. Well, what we have here is we have a circle that has 2 chords through it. Nothing says that any of these chords go through the center, so I can't say it's a diameter. I'm not saying that any of these chords are meeting, as in intersecting, at any particular size angles. Okay? They're any chords intersecting inside. What it says, guys, is that the product of the length of the segments of one chord equals the product length of the second chord. So what does it mean? It means this. X times Y is equal to P times Q. So if you know 3 of those pieces, you could find the 4th. It's not that big of a deal, right? And going below, it says that if you have 2 tangent lines, which I think we talked about yesterday, that if the tangent line actually forms a right angle with a radius, yes? They end up being the same, those tangent lines' lengths to the circle M and N are equal. Watch this. I can actually do a really quick, short proof for this one. Would you guys agree that I could say the center is in the circle someplace there? Yes? If I connected or created a radius to the point of intersection, where it's tangent, both of those would be considered a radius, and they are the same. Right? You guys following that? All radii are the same. So those would be the same. We also said yesterday that those radii and the tangent lines meet at what kind of angles? 90? So they're both right. Right?
Yes.
Now, watch this. What if I drew a line, segment, connecting to the point on the outside to the center? I would actually form 2 right triangles.
Yes, you would.
According to the reflexive property, that red line down the center is shared by both. So therefore, it is the same. Would you guys agree that that would also be congruent to themselves, to each other?
Yes.
So according to which congruency postulate, those 2 triangles are congruent? I'll tell you this, it's not side, side, side.
Side, side, angle.
Side, side, angle, no.
Side angle side.
I don't have a side, angle, side. Remember, these only work, guys, when things are in a row. So for side, angle, side, I'd have to have a side, then an angle, and then another side right away. Do we have that?
No, it would be a side, angle, angle, side.
Right now,
Angle side.
I don't have angle, angle, I only have one angle.
What?
I have 2 sides and an angle. Wait a minute, that's ASS.
Donkey.
But there is no such thing as a donkey postulate. Stella, what?
HL.
It's HL, which was what again? That was the one that was kind of obscure. Hypotenuse leg. Hypotenuse leg only works for what kind of triangles? We have them here. Right triangles.
Right.
Guys, here's the thing. We did our proofs, and then we said that if you can prove 2 triangles are exactly the same, that would mean what about them? Means they're congruent, yes. And if things are congruent, everything about them is the same. And then there was that phrase, corresponding parts of congruent triangles are congruent. CPCTC. If these 2 triangles are congruent, then M and N have to be congruent because of CPCTC. We just proved this, guys, that m is equal to n. Very cool. So now we can use it. Are you guys ready? Find x and find y.
Alright.
Oh, baby.
This is definitely not what you just said there.
So, as we're looking at this particular problem, I'm hoping that you guys see that it's a circle. We happen to have angles given to us. It actually looks like they have a whole bunch of lines crossing in there. And we're only talking about angles in this one. We got a 30, we got a 46, and then it jumps over here to y plus 20 and x plus 10. So let's actually write some things down we know about this. Isn't A, the angle at A, isn't that an inscribed angle? It's an inscribed angle to what? No, hold on. What is A an inscribed angle to?
P. PR. 46.
PR. Arc PR. So what do we know about arc PR? How big is it?
36.
60. Why is it 60? Because an inscribed angle is half of the arc. So if the angle is 30, the arc has to be 60. Wait a minute. Look at this. 60 PR is also, and you can trace the lines back to B. So that means B is also an inscribed angle to 60, which means angle B is worth how much? 30. Guys, inscribed angles are half the intercepted arc. It opens to 60. So that means 30 equals angle B. But angle B was, or is, y plus 20.
Y plus 20 and you minus y plus 10.
So y, yes, will equal 10 when you subtract 20. Okay? Can you guys do the same thing to solve for x? Try it on your own. Okay, changing colors. Now, look at this. Angle 46 opens to this arc here, which means that red arc is double 46.
Yeah, so 92.
So 92. But wait a minute. Part R, or angle R, also opens up to that same exact arc, so it is half of 92, 46. But wait a minute, R was more than just 46. They said R was equal to, who was that, Alex? Oh, AJ. So x plus 10 is equal to 46.
Okay, this actually makes sense now.
36 degrees. Hold on.
Yeah, I see.
The next problem, guys, solve for x, y, and z. I'm going to give you guys a couple seconds here of your own time to start this, try this, and we'll come together and talk about it. Okay, guys, this one takes a little bit of thinking because it gives us 75, it gives us 80, but then it asks for x and y, which is no triangles. It just seems like it's just big quadrilateral that sits in the middle of a circle. And then it has z on the outside. Now, guys, I would assume, because it has z out there, that z is only asking us for this little arc there. Okay? It's the arc, not something else. Okay? Now, here's the cool thing. We know that 75 degrees and 80 degrees actually is or are inscribed angles. I know this because they are touching the back or the outside of the circle.
Okay.
So this angle here, sorry, I'm going to change. This angle of 80 is an inscribed angle from here all the way over to here. So guess what? This angle is how big?
80.
100.
What, Grace?
180.
Not 180.
Just 80.
It's not 80. No, it's 160. The 50 is not part of this particular point with 80. As in, like, you don't add it to it. Guys, 80 is an inscribed angle where it starts here, stops over there. So all of this has to be twice the size of 80, which is 160. Yes, if you want to find z, you now subtract 50 because 160 is made up of z and 50.
Oh, so it's 110 then.
So 160 is equal to z plus 50, or z is equal to 110 degrees. You found z.
So is this all we have to do for like all the problems?
And then now you can start to find the others.
And that's all like you just find.
You just got to keep working your way around a pattern.
Okay.
Hey, can we do the same thing with 75?
Well, oh, couldn't you do 75 to y?
Doesn't, guys, does 70 open up to that angle? And that angle would happen to be
Y.
150. Which means this arc here is how much? 100. How did you get 100?
Because you do 150 minus 100.
It's 150 minus the 50 that was given to us. Whoa! Wait a minute. We have z. Watch, I'll put z up here. Z was what? 110? We know 50. We know 100. Can we find that fourth arc? 360
Oh!
minus 360 minus 110 minus 50
So 160
minus
200, so 50.
100.
It's 50.
Is it 50?
Yeah.
Oh yeah.
100.
Okay, so it's 100.
Whatever. I was.
Does everybody see how I got to 100? But why was it important to find that? I know all of the arcs, which will lead me to find all of the inscribed angles. Guess what? X goes from here all the way around to here. How many degrees does that traverse on the arc? 200. So x has to be 100. X is equal to 200 divided by 2, which is 100. Can I do the same thing to solve for y? Y goes from the purple line to the purple line on its far side, which is made up of 100 and 110, which means y is equal to 210 divided by 2, or 105. Hey guys, what's 75 plus y?
75y.
What's y again?
Oh.
105. What's 105 plus 75?
180.
What's 80 plus 100?
180.
Guys, what's the property of a quadrilateral? Opposite corners will add to 180.
Oh, Nick.
So, we are able to find it a couple different ways. Okay, find x, y, and z. Go. Okay, guys, we should be able to move pretty quick. What's y?
70.
It's equals 70s, twice of 35. What's x? 150. It's twice of. And what's z?
140.
Why do you get 140?
Because that's what's left.
360 minus the 150 minus the 70 only leaves you with 140. That's how fast these can go. Next one. This one. Oof. Okay, this will be the last one we're going to do today.
Alright.
We'll do the quadratic formula tomorrow. This one is talking about the line segments, the chord segments. So what can we say about this? If we use the letters from the example that we had, it would be x, y equals PQ. Sometimes some people put it as AB equals CD. Well, what did that stand for, guys? What did that stand for?
So basically it's like taking 15 times x plus 10.
Yeah, and then equals 20 times, yep, equals x times whatever.
Yes. Guys, chord segment of 15 times x plus 10 is equal to 20 times x plus 5. You could have those reversed order, yes? You just have to make sure you put the 15 and the x plus 10 together and the 20 and the x plus 5. And from there, guys, find x. Here's a cool thing. They're both sides are multiplied by 5. Could I do this instead? I just divided both sides by 5. Smaller numbers. I don't know. So 3x plus 30 equals 4x plus 20. Subtract 3x from both sides. I get what? X on this side. Subtract 20 from both sides. I get 10. You guys had to divide by 5, didn't you? I did it first. You guys did it last. It doesn't matter, does it? Math is a beautiful thing, guys. Embrace it. It will embrace you back and it'll feel like a warm hug.
Ew.
Page 88. This is day 2, 5, 6, 17, and 20. Have a great day.